Okay, here's another data set I have for SPSS. I actually kind of this is a form. I put together this form so that if you want, you can play with it. It's also on Blackboard. Descriptive Statistics exercise. Now, the reason why I like to do this, it's a good Excel exercise. Get a little practice with Excel, number one. And number two, it reconnects you with how these calculations are made, where these statistical terms come from. Standard deviation, variance, sum of squares, where all this stuff comes from. In other words, it's not just pull out of the air, they're actual calculations. Okay, so first thing we're going to do is I'm taking a look at this list of values, A2 to A19, that's 18 people, I think, right? Or is it 19? 19 people. A19, A2, 17, it's 18 people, right? So I'm going to first calculate the average for that. So the average is going to be equal to mean, or the average is going to be equal to, the mean is going to be equal to the average of all these numbers. Okay, now it's about almost 100, 99.94. Okay, now the count, how many people are in there? Well, there's a function in here in Excel called the count if we wanted it. Right, there's a count. I could tell it what our range of numbers is. And it'll tell me, is that 18, 19? How many? It's 18 people. Okay, good. So now I say to myself, I want to create something which is a repeatable way of describing the variability in this data. Okay? So one way to describe the variability in this data is to look at the average and see how far away from the average each individual value is. Right? So if there's not much variability, you would expect each value to be close to the average. If there is a lot of variability, you expect each value to be far away from, a lot of values to be far away from the average. So what I'm going to do is I am going to take the average and I'm going to put it in here. Okay, here's the average. Okay, this is equal to this number down here, 99.94. There's the average. Okay, so now I'm going to copy that value all the way down. Oh, what went wrong there? It thought it was an adjacent column with those doing the calculation, didn't it? Right? I need a way to replicate that number. In other words, when I first put it in here, that is equal to B21, where the average is. But the next one, because it was in a column, is equal to B22 and B23 and B2, which are empty cells, right? There's a trick that I can show you now, which is something that most of you have never done in Excel. There's a way of addressing, there's two ways of addressing, called absolute addressing and relative addressing. If I just type in B24 and copy it down, that is relative addressing. It's taking that cell number, and then as you copy it down, it's advancing the cell to B25, B26, and so on and so forth. We can avoid that. Instead of calling it B24, we can put a dollar sign in front of the B and a dollar sign in front of the 24. What that tells it is that, oops, I'm in the wrong cell. What that tells it, dollar in front of the B, dollar sign in front of the 21. What that tells it is now when I do a calculation or I copy that down, keep that same cell value. Don't advance the cell value. That's called absolute addressing. Okay, good. So I'm gonna do that. You may have noticed there's another way I can copy down. I don't have to go to edit. I can just grab the corner down there and drag it down. And this time it'll keep the same reference. So they're all 99.44. Okay, so the next column I have is going to be my difference between the mean and each individual value. So it's just going to be equal to x, is equal to x, which is the value for that particular subject, minus the mean. Okay, and that's equal to -1 basically, right? It's one less than the mean. Okay, so gee, that's great. Now I'm going to do that for all of these people. So I'm going to go ahead and copy that down. So the calculation is going to go across. So I'm not going to use absolute addressing. I'm going to use relative. So it does a calculation for all of these individual values. Okay, so that's good. Now I have all of the differences. Now I'm going to say, okay, I want to add all those differences together to see how big they are. So I'm going to take the sum, I'm going to do it in here, of all of those differences. Anybody want to hazard a guess what I'm going to get? Did I hear a zero somewhere? Yeah, it's going to be zero because some of them are positive, some are negative. They're all going to cancel out, right? It's basically zero. 2 to the minus 10 to the negative 17 is basically zero, right? So I can't just do that. Now I have an option. I can either just change all the signs and call it the absolute value, or what's another good way of getting rid of negative signs on numbers? I can square them, right? That's what I'm going to do. So I'm going to go up here and I'm going to take each one of these x minus x bars and I'm going to multiply it by itself. Equals this times itself. Right? Okay, so now that negative sign becomes a positive sign. Value changes a bit, but it becomes a positive sign. Okay, so I'm going to add them all together. Okay, now there they all are, right? See, in other words, this difference was 4, now it's 16. Minus 11 is plus 142. So they're all positive. So I'm going to add these all together. Okay, let's add them all together. Okay, and I wind up with 893 basically. Okay, so what have I done? I've taken the difference between the means and the each value. I've squared it, and I've added them all together. What's a good name for that? Sum of the squares of the differences, right? Or in short terms, sum of the squares. That's an expression you'll see in the future. You might have heard it before, except you didn't have a dummy like me sit here and actually do it, most likely. But that's the sum of the squares. Now, there's a problem. This number represents, it's kind of a measure of how variable this whole thing is. If this is a big number, it suggests the differences individually are probably big. If it's a small number, it suggests the differences are small, right? But the only problem is I've squared it, right? So now the magnitude of that number has blown up the differences. So now let's go back into the order of magnitude that the original numbers were in by taking the square root of it. So I'm going to take the square root of the sum of the squares. Is there a function in here called square root? Let me think. SQRT parentheses. I'm going to click in here, and I'm going to hit enter, and I come up with 29.88. That is what I'm going to call from now on the variance. It's a measure of the variability of the data that I'm working with. Okay, that's nice that we have that, but that variability represents all of the variability throughout this data set. I want to take a look kind of like what the average variability is. I'm going to take that 29.988 and so on, and I'm going to say that, oh, actually, I'm sorry, I just made a mistake. You let me get away with it too. Now I know there's a good reason why I'm doing this, and you don't actually know all of this stuff. The variance is going to be equal to the sum of the squares divided by the number of values that we have, which would have been 18. We're going to cheat a little bit. We're going to call this degrees of freedom, and instead of 18, we're going to use 17, the sample size minus 1. Trust me for the time being on that. Okay, I'm going to hit enter. Oops, I didn't put anything in there. Equals 892 divided by 17 and minus 1. The variability is 52. Okay, sorry I had to step back there and correct myself. The variability is 52. That's just basically kind of the average of the sum of the squares. The mean. In fact, later on we're going to talk about a function called analysis of variance, where we talk about that being as kind of an average of the differences. So now that's 52. That's great, but it's still squared. We haven't got rid of that square number yet. So now I'm going to take that variance and I'm going to take the square root of it to really bring these differences into a kind of a sense of an average difference. Okay, so that's going to be equal to the variance, the square root of the variance, SQRT, parentheses. I'm going to click into the variance, hit enter, and I get 7.24. Okay, I think we used that number before, didn't we? We saw that number before. So that is what's called the standard deviation, right? By the time we're done this semester, when I say standard deviation, a wave of nausea is going to come over the this room. We're going to talk about it so much. Very important factor for us. It's a measure that we're going to use from now on to describe the variability of a sample, right? Or a population for that matter. Okay. So here's some important stuff. We got mean, we got median, we got the variance, we have the sum of squares. Now we have the standard deviation. This is how we find it. Are we ever going to do this again? The answer to that is no. Because instead of doing this, if I want to know what the variance is, I can just type in equals VAR, give SPSS a list of numbers, and I'll get the same number I got by going through this whole operation. If I want to know standard deviation, equals standard DEV, parentheses, go through the same set of numbers, and I've calculated my standard deviation because SPSS is a function that will do that calculation for us very quickly. Okay? But that's where these numbers came from. Okay? They weren't just pulled out of the air. And in a sense, you could almost sit here and invent your own statistics, right? You could have, except for maybe that n-1 instead of the n for the average variability. You might have been able to just do this, invent this yourself, right? So instead of those, you see on the web page, I put up that banner with all these old statisticians and stuff like. You could have been there. Who knows? You could have been among those guys. Okay. So at any rate, so that's one of the ways we might describe this. Minimum and maximum and range we've already taken a look at. Another thing that we might be interested in that describes the variability is what we would have gotten had we seen a box plot for this data. Right? Remember the box plot? Okay. What are those feathers all the way at the end, at the bottom, and the other end? What do they represent? The feathers all the way at the end, right? I'm going to draw. Hey, I'll draw something for you. Let's see if I can't do this. Cheat this in Excel. Okay. Where is? Let me see if I can't find this. That. Okay. Let's make that. And this, I'm going to make one of these. Go on the top. Where's the top? Let's do this one. Top, bottom. Okay, there's the bottom. There's the bottom again. Notice that you can, like I said, you can do a lot of stuff. I'm just doing this because it occurred to me to use Excel to do this. But you can imagine this. The flexibility of this program is pretty good, right? Do so many different things with it. Okay, left border, right border. Where's the right border? Okay, so what do we have there? We have, if I can you see my mouse there? We have at this end, we have a feather here and a feather here. The whole range there, what does that represent? I just gave it away. That's the range, right? Yeah. This feather is the lowest value. This feather is the highest value. I'm talking about the thin line that's over here, right? And the distance between the lowest value and the start of this box, right, is what? What does that represent, that distance? Bingo, 25th percentile. In statistics, we often call that the first quartile, right? First 25%, right? That's the first quartile. So the minimum value is here. The maximum value is here. We can calculate that, can't we? We have functions in Excel. I'm not going to bother at this point. Okay, this line, which represents the 25th percentile, 25% of the values below it, 75% of the values above it, is the 25th percentile. Well, you know what I'm going to do? I'm going to actually calculate that. There is a function in Excel called percentile. I'm going to hit parentheses, and it's going to help me out. It's going to say, put in the array, that's the list of numbers, and then comma, and then put in the percentile that you want. They call it K here, but I know that K. If you go into the function and look up percentile, it'll help you with that. The K is the percentile, which is 0.25. Okay, I'm going to close that, and the 25th percentile is 94.5. 25% of the values are below that. Okay, what is this number up here? Oh, where is it? It doesn't look like it. I'd have to stretch this out. It's more like that. What is this value here? 75th percent, right? The median is the 50. It's going to be in here somewhere. That's the 70th percentile. Equals, again, percentile. Parentheses. And I'm going to go over here to list all the numbers. Okay, hit enter. Whoops, I messed that up. How did I do that? Percentile. Should work. Now, let me try this again. Equals percent. Oh, you know what it was? I didn't put it in as a. Yep, yeah. I didn't use a decimal point. Percentile, comma, point. Where is it? 0.25, 0.75. Okay, and that's 104. So 25% of the people below 94.5 and 75% of the people are below 104. So what does that leave the difference between those two? That's called, it's going to be, the difference is going to be called the interquartile range. Exactly right. Right? That's between the two lowest and highest quartile. The interquartile, that represents 50% of this population. When we look at normal distributions, that's going to be an important area that we're going to be dealing with, because the people on the outside can kind of fool us a little bit, right? But that's going to give us a better look at the minimums. That's our interquartile range. Those are all numbers that we could, if we wanted to do it manually, use to construct our own box plot if we wanted to. Okay, how are we doing on time? Okay. Now, we didn't even get to SPSS now, did we? Well, it doesn't matter, because SPSS, the same thing, is going to go really quickly. Okay, so now, I am going to take this data that we had here. Here's the data as an Excel file. You see it? I'll blow it up so you can see it. Those are the same numbers I had before. Right? Okay, so I'm going to take those, I'm going to save it to the desktop. Okay, I don't care what name I'm going to give it for right now, Descriptive Statistics, so on and so forth. So I'm going to save that. It's a very simple Excel file. No, there's no header, right? There's no label at the top. It's just 18 numbers. Okay, so we could have labels at the top if we wanted to, right? And I'm going to show you that in a second. I'm going to go over to SPSS and open SPSS. First thing I'm going to want to note is, what does SPSS look like when it opens? Go. Good. There we go. SPSS, when it opens, is like a lot of other products, has kind of a template. You know, when you open up Microsoft Word the first time, it comes up with a whole bunch of templates. You could choose a blank paper or so on and so forth. Most people turn that off. I left it on here just so when you open it the first time, you'll see that. You can tell it, I don't need that, I don't want that. Or you can learn how to use this and navigate through files that you have or recent documents and so on and so forth. I'm going to leave it on there for our purposes anyway. Okay, but the actual file, I'm going to click that away. The actual file that opens up looks like this. What does it look like? What does it remind you of? Yeah, it looks like an Excel worksheet, doesn't it? It's nothing like an Excel worksheet. All it is a data storage device, a place for you to list and write data. The columns represent variables. So each column could represent a different variable. The rows represent data points, subjects. Subject number 1, subject number 2, subject number 3, subject number 4. Going back to the columns, variable number 1, that's the patient number. Variable number 2, gender. Variable number 3, weight. Variable number 4, height. Variable number 5, a calculated one, maybe BMI. Variable number 6, blood pressure, so on and so forth. Each one of those columns represents a variable. So now, that data that I have here in this Excel file, I could have copied it and pasted it in here. None of these cells represent calculations. You don't use the cells to represent calculations, you just use them to represent the data. Okay, so in order to get this data in, I can either just copy and paste it in, pretty awkward, type it in, even more awkward, or I can import it. I'm going to say open data. Okay, and I'm going to navigate to the desktop. And you may see here Descriptive Statistics. Where did I save that? Is that it? I guess I already imported it. Okay, I'll open that. Yeah, okay, I guess that's right. Okay, so it copied this data. Is it the same data? I'm not sure. How many, what was the count before 17 or 18?
18.
18. Oh, okay, that's not the same data. I don't want to. Hang on a second here. Let me see where I saved it. Let me open up Excel again. Open recent. Come on, come up. Save as. Desktop. Oh, it's there. Okay. Well, I'm going to quit Excel. The reason why I'm quitting Excel is because if that file is open in Excel, SPSS will not import it. Even though it's saved to the desktop, if it's open in another program, it won't import it. One of those glitches that, they apparently would be too much of an investment for them to fix rewriting the program, so it never gets fixed. Okay, so I'm going to say open data, navigate to the desktop. Now, hang on a second. There is a Descriptive Statistics SAV file on there. .sav file is an SPSS data file. I see that on there. I don't see my data file on there. Why don't I see my data file on there? Because right now it's only looking for SPSS files in that folder. In order for it to see other files in that folder, I have to tell it what file types to look for, or just tell it all files. So it's going to show all the files now. Or if I know it's an Excel file, I can tell it to just target Excel files. And there is the Excel file that I am interested on the desktop. There it is right there. That's an Excel file. Okay, that's the one we were just working with. I'm going to click on that, say open. And now it's going to import that Excel file into SPSS. And it tells me it sees data between A1 and A18, what I expect. It's also asking me, okay, let's see, read variable names, read variable name from the first row of data. Notice that's unchecked. If at the top of that row there was a label that said blood pressure, we would check that off. So when it gets imported, it would use the value in there as the variable name, if it could. Okay, so I'm going to uncheck that because there wasn't that, and there was just a row of numbers. And I'm going to click OK. And SPSS will open up with that data now in an SPSS file. Okay, you can see there's 18 values now. Now notice it gave it a temporary variable name called V1, variable 1. We're looking at the data window for SPSS. This window, this single window, really has two forms, has kind of a front and back. If you look at it kind of as front page, back page kind of thing, you can flip it between this view where we see the data and another view called the variable view where we see the properties of the variables. So since there's only one variable, there's only one row on this side. So I have the opportunity now to give it a new variable name. And I'm going to call that new variable name BP 2040. Maybe it's BP for people that are between 20 and 40 years old. Few rules in naming variables in SPSS. Got to start with a letter. Can only have letters and numbers. Can't have any special characters. Can't have spaces. A little bit inconvenient, but you can get by with it. Okay. The problem is that when we create a table or a graph, BP 2040 is not going to mean anything to most people except for us. So if we want to use that table or graph somewhere else, it's going to be a little bit awkward to do that. So we have an opportunity now to customize this variable. Well, for starters, realize that it's numeric, that they're all numbers that are in that column. It says that the width is 3. That's the width. That's the maximum width of the data. I could change that if it was going to be. If I thought there might be a value that's 4 digits wide, I could change that to a 4. There happen to be all numbers, so it just assumed decimal place is 0. If I wanted to, I could tell it that there is one decimal place. I might want to change the width to 4. So I put in we're going to see all zeros, but it'll display a decimal place now if I wanted to. Then the next thing we see here is label. This is the point where we can take that variable name and change it into something more descriptive, such as blood pressure, 20 to 40-year-old males. Okay, so now whenever we create a table or a graph, it'll use that in place of the variable name. Yes? There's a couple of ways to get you to the variable view. Okay, there's a couple of ways. One way is to click down at the bottom here where you see data view and variable view. You can click back and forth. And the other way is just go up to view, and you can toggle back and forth between the data view and the variable view. Okay, so now if I go further across, there's another important thing down here, and that's the under measure. What kind of variable is it? We talked about how important that is because different kinds of statistical tests are going to be appropriate for different kinds of data. If we are dealing with numerical data, we're going to calculate means, standard deviations, so on and so forth. We're talking about categorical data like gender, right? Then that's not going to be appropriate. We're going to calculate frequencies and things like that. So we want to make sure that SPS realizes that this is among the three choices of scalar, which means numerical, ordinal, or numerical, that it realizes that it's scalar or numerical data. Right? Usually it'll guess correctly, but in case it doesn't, you can check it. Okay, so now we're set up. We can go ahead and start working with this. We want to analyze, we want to calculate our descriptive statistics for a numerical variable. I'm sorry? Oh, you won't see the label yet. You only change, all you're seeing right now is the variable name, right? You're not going to see the label until you produce a table or a graph. Okay, so now let's calculate our descriptive statistics. So I'm going to go up here and just to show you how difficult it is to use this program, there's something up here called Analyze. I click on that, and under Analyze, I see Descriptive Statistics, and under Descriptive Statistics, I see Descriptives. And I'll click on that. Next thing I see is a box up here. Now keep in mind that most of the time, you're going to have a lot of variables, a lot of columns. So SPSS probably going to want to know, well, I'm going to do a calculation. I'm going to analyze something for you. Which of these variables do you want me to do this analysis on? So it gives you the opportunity to pick out the ones. In this case, it's only one variable, and move it over into the box where you're going to actually do this work. Then you go into options. It's already checked off to calculate the mean and the standard deviation, minimum, maximum. Let's do the variance. Let's do the range. Okay, I'm just adding them on there just for the hell of it, right? And I'm going to click Continue and click OK. Now what's going to happen is a new window is going to appear, an output window. SPSS has a data window where it stores the data and the data description. It has a separate window where it puts the calculations. And it's kind of like one of those calculators with a ticker on it, paper, where it continues to add your latest calculations below that. So you're going to scroll back and see all your previous calculations. So if you go down here, okay, unfortunately, like I said, it won't let me blow it up, but I can raise it up a little bit anyway. Okay, if you look at that, if you're doing it at the same time, you can see that the sample size is 18, the range is 26, the minimum is 88, maximum is 114, the mean is 99.944. Looks familiar. The standard deviation is 7.275, same thing we calculated, and so on and so forth, the variance as well. So it did that calculation for us basically in no time at all, right? Very fast, very efficient. Also means if you do it wrong, you can screw up really fast and really efficiently as well. I used to work for somebody that when we first started using word processes in business, he refused to let, back in those days, people had secretaries. I haven't seen a real secretary in 30 years, right? They had people that you would write stuff out by hand. You'd hand it to them. They'd type it up. They were male and female secretaries. They type it up. I remember one guy that was a secretary. He could type 150 to 200 words a minute. Accurate, dead accurate. The guy was blazing. So you would hand it to them. They'd type it up. You'd get a typed version of it back. You'd read it. Oh, no, let's change this. Let's change that, so on and so forth. And you'd hand it back to them. They'd retype it. You get it. There's a typo in it. One typo. Hand it back to them. They type it again, right? Anybody know who Peter Nesbitt's mother, who Peter Nesbitt was? Anybody ever hear of a group called the Monkees? Peter Nesbitt was a member of the Monkees. Peter Nesbitt's mother was a secretary, and she hated having to retype something for one little tiny error. So she went home, and in her kitchen, she mixed up a little bit of white paint and a little like paintbrush and stuff like that, and she started correcting her errors with that and typing over them. And the other secretary she was working with all loved that, so she started putting in the little jars for them. And she started a company called Liquid Paper, right? Or white was it liquid paper or whiteout? I think it was liquid paper, right? And that's how that family became ridiculously wealthy after 3M or something like that bought that from them. That's what they would do back in those days. So at any rate, the reason why he didn't like using, he was very reluctant, he's old-fashioned, very reluctant to use the word processor, is he told me, after I would argue with him, he told me because you can make a mega mistake. And what he would call a mega mistake is a mistake that a normal human would never, ever be able to make in real life unless they used a word processor. And he gave me an example. He showed me a letter that, like, because they cut and paste stuff on word processors. He showed me a letter with the 2 paragraphs in there, had nothing to do with the letter, had something to do with something completely different that got into this letter that he sent out. So he looked like a moron. The problem with good, efficient software is you can make big calculations very quickly, but you can also make big mistakes. So you got to be careful with this stuff. So it's worth learning how to use this stuff. Now I can do more with this as well. I can go in here and I can say analyze descriptive statistics, and there's another version here behind descriptives where it says explore, where I can even do a little bit more with this program. I'm going to move it into that box next to that, and now I can tell it to do, well, it's already set up to do a lot of statistics, and it just checks off descriptive, so it's going to do a lot. Then I can go into plots and ask it to do a histogram for me, right? So it will also calculate a histogram, reduce a histogram for me. So I'm going to click OK, and what window is going to come up now? The output window is going to come up, and now my new results are going to be on that output window. Okay, and what do we have now? Well, now we have not only the original statistics, but many, many more things. The variance, the minimum, maximum, the range, interquartile range. We have all sorts of other statistics that it's calculated from that sample of 18 numbers. It also produced a histogram for me, so I can see graphically what the distribution of this data is. It gave it to me in a couple of different formats. It produced a box plot for me, so I could see the lowest value, the highest value, where the median is. Notice the median is not really in the middle. Right? That's a sign that the data is not evenly distributed, that it's skewed, right? You can see there's kind of something funny about the way that data is, right? Because that median was not really in the middle of this range of stuff, this range of numbers. So I can kind of catch that just by looking at the box plots. But now, if you look closely, instead of saying BP 20 to 40, what does it say on the bottom of that graph? Blood pressure, 20 to 40-year-old males. Right? Instead of using the variable name, it substituted the label. That's what, and so that way you could say, oh, gee, look at this table. Blood pressure 20 to 40-year-old males. Now it means something to someone else that's reading about your data. And you can highlight that, copy it. You can open a copy of Word or a page processing program, or a page layout program or something like that, and you can paste it into that program. My version of Word is very slow starting up. So I always have to wait for it to kind of wake up. That's the danger of doing the required updates. Oh, there we go. I think it's awake now. Come on. There it is. There's that table now in a Word document. What does that mean? That means you can do your calculations, produce your graphics, do all sorts of stuff in Excel, in SPSS. Take those tables, copy them very neatly into your presentations, into your research, into your projects, and so on and so forth, into your epidemiology homework, and so on. So now the one thing that I want to remind you of is that we have separate windows here. So if I save my data window, I'm not saving my output window. You have to save them separately. right? Otherwise, you won't have that output window to open up. Don't send me output when you reply to the homework. Copy and paste tables and things like that into Word documents. Unfortunately, some of you might be using different versions of SPSS, 24, 22, 23. Sometimes those output tables don't work too well with different versions. So it's important that you always copy your answers into a Word document. It's good practice anyway, because most of the time you're going to be communicating your data to people that don't necessarily have this program. Remember, it's an $800 program minimum if you had to buy it, like off the shelf. So they're not going to have this. So you're going to want to be able to communicate your data with them in a form that they can easily read, open, and read, so they have access to. So you want to save them separately. The other thing I want to point out to you is that each time I did a process, SPSS in the output table put together this list of kind of weird, kind of almost English-like instructions. That's a language, a programming language, a syntax that's built into SPSS that you can use to redo that same calculation, repeat that same calculation by copying that into a third window called a syntax window and telling it to run those instructions. You can also create a operation where if you're getting data every day from field workers or something like that, that you can use those syntax windows to open the files that you're getting, import the data, redo your calculations, and so on and so forth, and automate these functions in SPSS. There used to be a professor in the math department that when he would do demonstrations using SPSS, he would use this to document how he did the calculations. Right? So you can go through this step by step and say, oh, it opened this file, it did this, it calculated this, and so on and so forth. You won't have to do that if you don't want to. You can use the drop menus for almost everything we do, but there are occasionally some functions that are not accessible through drop menus that are kind of extended functions in SPSS. Maybe not in your version, but in more advanced versions. Any questions? Come on. What did I say? Yeah, there you go.
Is there a way to change the label in your output without going
Well, actually, to tell you the truth, in your output, you can go in there and double click on the table or on the graph, and you can actually edit it. An editor will come up. Good question. An editor will come up. I was just, Levi, I was just telling them when they didn't ask any questions when you left here. On occasion, I've run lectures where people have come to an organization to give a lecture, and we always would plant people in the audience to ask a question because it's rude if nobody asks a question, like nobody's interested in it. So that's why I was looking up and I was glaring at them when I asked if there's any questions. So you can actually go in here and, for instance, on this graph, you can double click on that. It'll open in another window, and you have all these editing tools in there. You can edit the text, make it bold, change colors in the tables, change numbers if you want to fake data. I didn't really say that, did I? Right. So at any rate, yeah, you have a mechanism for doing that in SPSS. And again, it's such a rich program, Excel and SPSS both, that the way you're going to learn this is not from what I'm showing you here, right? But by actually doing it yourself, actually going in and playing around with it. Okay, and we're at the last 5 minutes, and I just want to demonstrate a really cool application using graphics to demonstrate something. Yes, sure. Yeah, you want to know something? Yes and no. There's a couple of ways. If you just say paste the table, right, you can edit the table. If you say paste special and paste it in as an image, you can't edit it, right? Now, the advantage of pasting it in as an image is easier to resize, right? But then obviously the disadvantage is that you don't have the option of, let me quit this.